We'd go with the factor theorem. A polynomial divisor is a factor of a polynomial p if division p of x by d of x results in a remainder of 0. So the number c is a 0 of the polynomial function y equals p of x if and only if x minus c is a factor of the polynomial p of x. So it's a factor, gives you a remainder of 0. This is the form of 1x minus c, so we can use synthetic division to test this out. So finding out if x plus 4 is a factor of p to the x, remember it's x minus c, so in this case c equals negative 4. So negative 4, 3x to the fourth, 0x squared minus 48, or 0x cubed minus 48x squared plus 8x and 32. Bring down the 3. Negative 4 times 3 is negative 12. Add is negative 12. Negative 4 times negative 12 is positive 48. That adds to 0. Negative 4 times 0 is 0, plus 8 is 8. And negative 4 times 8 is negative 32. And the remainder is 0. So yes, x plus 4 is a factor. Let's try it again on this longer polynomial. Again, it's x plus 4, so we'll use a minus 4 for our synthetic division. 1x to the fifth, 6x to the fourth, 11x cubed, 12x squared, 5x minus 20. Bring down the 1. Negative 4 times 1 is negative 4. Add is 2. 2 times negative 4 is negative 8. Add is 3. 3 times negative 4 is negative 12. Add is 0. 0 times negative 4 is 0. Add is 5. 5 times negative 4 is negative 20. And the remainder is negative 40. So no, x plus 4 is not a factor. So just some summary. C is a 0 of p to the x. Then x equals c is a root of the equation p to the x equals 0. P of c will equal 0 by the remainder theorem. X minus c is a factor of p to the x by the factor theorem. And c is an x-intercept of the graph of the function y equals p to the x. Now, the fundamental theorem of algebra. If y equals p to the x is a polynomial function of positive degree, then y equals p to the x has at least one 0 in the set of complex numbers. Now remember, real numbers are a subset of complex numbers, so it doesn't have to have an I in it. Next up is the rational numbers theorem. If the coefficients of the polynomial p of x equals a sub n of x to the n plus a sub n minus 1, x to the n minus 1, you can see my exponents are getting smaller, as are the coefficients, down to a sub 1 x to the first plus a sub 0, your constant, where your first coefficient is not equal to 0, are all integers. So that has to be all integers. P over Q and P over Q does not equal 0 is a rational term reduced to lowest terms. Then it's a rational 0 of the polynomial. Then P is a factor of the constant term, and Q is a factor of the leading coefficient. So notice it's the constant term divided by the leading coefficient. The proof of this is on page 276 in our table. The rational zero theorem gives all the possible rational zeros, but it doesn't tell us whether these rational numbers are actually zeros or not.